coming off a couple decades of zero or small load demand increase, this new demand has got to be requiring some change in plans. So what are you seeing in utilities and other power producers, and how has this affected the power engineering business?
Yeah, I mean, the demand is definitely there. There's a McKinsey report that says, in 2024, we're at about 25 gigawatts of demand for electricity for data centers, and that growing to approximately, I think it was 60 or 80 gigawatts by 2030. To put that kind of into perspective, the ERCOT, which is basically the electric grid for most of Texas, hit their peak demand of about 86 gigawatts this summer.
Welcome to this episode of the AEC Engineering and Technology Podcast, a podcast dedicated to helping engineering professionals find technology that fits their needs. Artificial intelligence and processors require an enormous amount of energy and is driving a new wave of power generation. Analysts at Wells Fargo suggest that U.S. electricity demand could jump 20% by 2030, driven in part to AI. Goldman Sachs predicted that data centers would account for 8% of U.S. energy usage in 2030, up from just 3% today. In this episode, I'm thrilled to be joined by Chad Daniel, Vice President at Stanley Consultants, to talk about how rising energy demand is reshaping the power industry and impacting data centers. We'll also dive into the latest trends in power generation, talk about the role of renewable energy, and the challenges of balancing AI advancements with environmental impacts. I'm your host, Nick Heim. This is the AEC Engineering and Technology Podcast. With that, let's jump into today's episode. Chad, welcome to the show, and thank you so much for taking the time to join us today.
Thanks for having me, Nick.
Yeah, absolutely. So, Chad, I know there's a lot to talk about today, some of which we got into before we started recording, but I'll start off with just some basic info for the audience. Chad, can you tell us a little bit about yourself and what led you to your current role as Vice President at Stanley Consultants?
Sure. I've had the opportunity to be with Stanley for, I think, 19 years now. I came into the company as an environmental scientist working on permitting and negotiations with utilities and the DNRs and those type of things, and kind of got a knack for also developing proposals and selling. And over the course of the last, 10, 15 years have really focused on selling our services and growing our business with clients across the country.
Yeah, excellent. And I think in that vertical or that market sector, Chad, I've heard, and I think all of us have heard about, AI, data centers, but really what it comes back to is this huge jump in demand for energy. And it seems sudden, although maybe if you were, in the know, you would have seen this coming. But coming off a couple decades of zero or small load demand increase, this new demand has got to be requiring some change in plans. So what are you seeing in utilities and other power producers, and how has this affected the power engineering business?
Yeah, I mean, the demand is definitely there. There's a McKinsey report that says, in 2024, we're at about 25 gigawatts of demand for electricity for data centers, and that growing to approximately, I think it was 60 or 80 gigawatts by 2030. To put that kind of into perspective, the ERCOT, which is basically the electric grid for most of Texas, hit their peak demand of about 86 gigawatts this summer. So when you think about that, we're really adding in a significant amount of electricity. And you're right, the utilities have been dealing with flat demand for a while, though they haven't been sitting on their hands. They've been really pushing the transition to renewable or lower carbon fuels. And so they've been busy the whole time, but they are certainly seeing some of the stressors that come with the immediate demand. It takes somewhere between 12 and 36 months to build a data center that can take substantial power, but it can take, upwards of 7+ years to build a transmission line that can move a substantial amount of energy from point A to point B. So there's a lot of conflict at this point as far as timing goes, but long-term, the utilities will definitely get there. For our industry, within Stanley, what we're seeing is a significant amount of demand for help around generation of all kinds, whether it's traditional bridging fossil fuels, natural gas recip engines, combustion turbines, those type of things, or the transmission and power delivery infrastructure. All of that is really, in demand right now, and It's almost have to take a number time at times. I mean, it is that busy in that world at this point.
And Chad, so speaking numbers, to whatever level you think is kind of appropriate, but like how much more power is going to have to be produced to meet demand?
The projections are that data centers currently take up about 4% of the United States electrical demand at this point. And that is anticipated to increase to at least 9% by 2030s. So it's really a doubling of all the demand out there, which is a substantial amount of energy to start, and doubling that over the course of less than half a decade or just over half a decade is really a challenge. Not only siting and getting them built, but dealing with supply chain constraints, permitting requirements, and all the other things that go along with it.
Right, which I'm sure all of those factors contribute to those numbers. Right, you said 2 to 3 years to actually build a data center, but 7 years to essentially build the infrastructure to power it.
Yeah, yes. And that's why you're seeing some delays on, retiring coal plants. Utilities are on a push to reduce their carbon footprint. They've been doing a great job of it. But some of these assets are going to have to stay in play just to maintain the electric grid over the course of the next, 5-10 years. And then you're also seeing in the news quite a bit, a lot of interest in reviving or, lining up agreements with nuclear plants that have been marginal in the electric space for the last 5 or 10 years, and bring them on just power data centers. And there's a lot of that activity going on, either with ones that were currently running and very, marginally profitable, to ones that they're taking out of mothball status and seeing if it's feasible to bring them back online to be able to meet some of the demand out there.
And so, Chad, we've talked data centers, but are there other trends in power generation that are also increasing demand and compounding the issue in addition to data centers?
Oh, sure. I mean, across the board, people are looking at electrification. It's happening in homes with heat pumps, those kind of things. But, the big drivers are things like the, reshoring of manufacturing in the U.S., which is being more electric driven rather than the old steam and those type of things. So along with electric vehicles, I know we've seen the kind of the trend up and then it plateaued a little bit, but that trend is just going to continue to increase, all of it requiring available, reliable, and affordable energy for everybody to be able to take advantage of it.
Which makes a lot of sense. And coming back to data centers, Chad, what market trends are shifting in the business of building new data centers?
I'm more familiar on the energy needs associated with it. So I kind of focus on that side of it. The data centers, there's some experts that certainly do that. We really deal with the infrastructure side, the water, the energy, that piece of it. But they are looking at how quickly can they either get onto a utilities system with the load, with the ability to serve their load, or what can they do to build their own generation and be able to serve their own stuff, either as a bridge until the utilities can catch up, or be able to serve their own needs. And really, it's kind of a fight between being able to have the electricity there when you need it. As we talked a little bit about a transmission line, you may have a data center in a place where it's real easy to put in, relatively easy to put in traditional generation, like reciprocating engines or combustion turbines. But the footprint you need for solar, for example, is going to be larger. So you got to be able to get that energy from point A to point B. But what we are seeing is a lot of them going ahead and moving forward with bridging opportunities. And some of those can take advantage of low or zero carbon fuels in the future. Some of the manufacturers are starting to tout the ability of their engines or the machines to be able to burn green hydrogen in the future, which, while the supply of that is not as readily available as natural gas today, you could see them transitioning generation fleets that were natural gas into hydrogen, making it basically a zero carbon availability of zero carbon source of energy. Additionally, trying to get behind the meter solar developments and everything else to power the data centers. The data centers are really driving renewable, but there's a time crunch there where things aren't lining up. So they've got to continue to move forward with different types of generation just to satisfy the demand.
And it's obviously it's not as easy as just snapping your fingers and getting renewable energy online to power tomorrow, right?
Right.
But companies like Google and Amazon are saying eventually renewable energy will be able to power these data centers, which are the core of some of their business lines. Are lower nor no carbon renewable sources going to be able to satisfy the data center load? Maybe not today, but eventually.
Oh, I definitely think so. You think back, the utilities had been transitioning that way for, last 10 plus years. And it's obviously a process. You got to make sure that things are reliable and safe. There's no doubt in my mind that over time that the data centers and companies like that will get the renewable energy, zero carbon energy that they want. It may be a combination of truly renewable like solar, zero carbon fuels like hydrogen, green hydrogen, and even a lot of interest now in small modular nuclear reactors. So there's a lot of different opportunities out there, but I don't see any of them giving up the race for an advantage to getting their data centers deployed by not dealing with and having bridging opportunities until they can get there. But I have no doubt that they'll get there.
Absolutely. And Chad, so from Stanley's point of view, it's like what types of professional services are going to be necessary to satisfy the data center demand from your guys' perspective, which it sounds like is more the infrastructure and getting the energy to the actual data center?
Oh yeah, it's all of the above. Everything from land acquisition right away, maybe even looking at the ability to look at the resilience of different areas to potential climate change impacts, through to, civil, mechanical, structural, electrical, instrumentation and controls. It is, an across the board demand for engineering services. And they throw in with that, like I mentioned earlier, permitting of everything from the transmission lines to the individual sites and the different types of generations. So we're seeing a significant amount of demand for services related primarily to the infrastructure. I mean, data centers' first two concerns are really power and water, cooling and the ability to run. And that, those are wheelhouse areas for us where we can certainly help people to make sure their infrastructure is in place.
And to the technology piece of how this eventually all comes about, right? So AI and big data, a lot of computing power. We put these, what is, the cloud, a bunch of computers, offsite data centers, right? How do you balance the benefits of AI and big data with the impacts of data centers? And I think everyone can realize there's like an environmental impact, right? But what other impacts may people not be thinking of?
Well, yeah, I think when people think about, the cloud and AI, they really, a lot of times, like, they think about the rest of the infrastructure that we use, whether it's water, wastewater, electricity, that, they all have an impact one way or another on the environment, but it's just sort of supposed to be there. And they don't necessarily understand what else is being driven. AI it's a lot more than Chat GPT or things like that. These are the systems that are optimizing emergency management services, helping us to be able to, have the modern economy that we have, the information, advantage that the United States shares. These are the things that are fundamental to what we're doing. And while some of the learning on AI may be energy intensive and things like that, the benefit to society, while it's kind of, like some of the other things we take advantage of, like roads and our water infrastructure and energy infrastructure, it's really a part of the fabric of what we do and how we run our country. So there's a lot of benefit there that I think people maybe don't recognize. It's more than a few novelty things on the internet. It really is serving as the backbone to making sure we're safe and our systems are reliable.
Which I think, like you said, underappreciated and maybe not that first level that people think about when they hear the term AI.
Right. Yep.
So, Chad, I mean, this has been really insightful for me because there's a whole world that makes, you being able to go to ChatGPT or another LLM, type some stuff in, get a great image or a text response. Like, there's a whole chain of things that need to happen to make that possible. And I think, you guys can really appreciate that since you're in the thick of it.
Oh, definitely. Yeah. Having worked in the energy infrastructure sector for the last almost 2 decades, it's amazing to be with the companies that are out there, keeping the lights on, keeping us with safe drinking water, keeping our transportation systems up and running. It's stuff that we all take for granted a bit, but it's really interesting to see how it works. And I think the AI data center part of it is really, can help all of us improve our standard of living and go from there.
Yeah, absolutely. Chad, what final piece of advice can you give AEC professionals and companies that are navigating this space, which just seems to be changing, not as fast as AI per se, but just seems like it's never able to just sit still?
Yeah, I obviously keeping up with the times and understanding what's going on out there is critically important for us at Stanley. It really is. There's so much going on that there's the ability to get a little scattered, I believe, and staying focused really on your clients, your communities, your people. It's great to have a whole backlog of, 15 projects, but if you're running your people into the ground to get them done, the focus on the best clients and the ones that your folks want to work with and giving them those challenging projects, there's a lot out there. And I think it's way too easy to think about, landing too much and either not being able to deliver or hurting your people. So stay focused on your clients, stay focused on your people.
Well said, Chad. And thank you again so much for joining us today. If the audience wants to connect with you, maybe ask you some questions about some of the topics we spoke about today, what is the best way for them to reach you?
They can reach me by my email address at danielchad@stanleygroup.com or my phone at 515-447-4411.
Excellent. So, Chad, it was a pleasure. Thank you so much again for joining us.
All right. Thank you, Nick.
Absolutely. Till next time.
Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.